Hi, welcome to my virtualization tutorial. Today I am going to discuss about clustering. In clustering, this is my agenda. So we start with the need of cluster, uh, why actually we need to have a cluster for running set of services, and what are the point of failures happens in a traditional way of running a service in a server or a node. Reason for clustering, why do we need to go for a clustering, and the fundamentals of clustering we discuss, and what are the advantages related to clustering, and we elaborately discuss about failover clusters, the types of failover clusters, and planning for failover clusters for different use cases and basically for different business scenarios. Okay. So when you see any organization, the organization basically depends on the data. So it may be a shopping cart application running by a company or any other organization. So every organization depends on the data. Or if you take a university as well, a lot of data is there related to students, faculty, subjects, marks, and so on. This really needed. Now here the term availability defines when this data is available. This is very important. I have a data. The data is available at any moment or not. That describes the availability. So the availability, even we can describe it in terms of another percentage of availability. Let's say that we can say that it is available for 99.9 and so on. We can define, sorry, it's skipping 99.9, or I would say that, okay, this is not my availability, my application is available only for 99. So 99.9 or 99 purely depends on the type of hardware I have. So normally in any business organization, the data is available for every second of every day. That is very important. Every day, every second, data is required, particularly in an application something like banking and the online shopping cart. This kind of application, the data is very important. Everybody is trying to access your application by 24/7, so your data should be available all the time. Okay, what are the reasons the data may not be available for the user to access or the application to access? So there are different type of failures would happen when you host your applications. So let's say your computers may fail, which is hosting the applications or which is running the applications, or the network may fail, maybe the cable fail, or network interface may fail, or switch or router, anything may fail. And storage, in case of storage, probably the partition of your storage may fail, or maybe the entire disk may fail. There are a variety of reasons related to each and every component failure. Now we'll see how we can a traditional system runs an application. So let's see this. This is a server which contains basic components, which is actually hosting an app. Let's say it is hosting an app. Okay. So this application, when you take any application, this and every application need a database. So database is the backend. So both of these applications are hosted in the server. Okay. So this server may fail due to various reasons. Its hardware may fail, operating system may fail, again network may fail. So normally this system is connected to a network. Okay, you have a switch. So on the other side you have a client connecting to again this server for accessing this app. So sometimes there may be a failure in your software itself that will collapse your system. So if we are not checking this aspect in terms of software, we are just trying to see what are the failures happens in the system. That's absolute necessity of a cluster. right? So how to solve these failures? So at any time your computer network or storage, this kind of things will fail. So this really helps us, the cluster really helps us how to solve this issue. This really ensure that the services are running 24/7. Okay, what's a cluster. Let's see the again we will see how we can define a cluster. So we can say that cluster is a group of computers. Okay, so you have different computers. All these computers are basically connected. uh, all these computers are basically, again, assume that it's a network. It's all connected. Connected to a switch. We can say that it's a switch. It's connected to a switch. So the end user from the other side, they'll be trying to access the application from this one. Now traditionally what we do, our apps and DB, everything, the entire application together runs in the single server. Instead, the same application now it's going to run in a cluster. So cluster is a group of machines, right? Okay, right. So two or more computers, two or more computer systems acting as a one. So then how do I identify my cluster? The cluster has a name, or it is identified by an IP. Now if I have a valid IP, so I can bind a domain name against it, so that it's going to be very simple, so that I'll be accessing all my apps with the help of that IP, right? So this is the way the business system runs in a cluster. Normally the cluster used to have a lot of backend nodes, which basically does the task for you, maybe updating in a database, retrieving data from the database, and listing it, doing some processing and so on. In the front end, you will have a load balancing cluster. So any client accessing your system or application, so coming from the internet, so landing the request to the master node, and again this is again flow to the backend node from here. So now you can see that it's separated. So this is only in a private network, so only the load balancer has an access to this. Now the beautiful part of this is all this data either uses a NAS based storage or SAN based storage. It's a shared storage, basically either NAS or SAN. It's basically a shared storage, so more than one host can access this storage devices or disk. Okay, so what are the type of failures happens when we run typically the apps in a traditional way? Okay, when we do it in a traditional way, definitely we can say that this system, there will be a lot of failures. The entire system may fail. Now what happens to the applications which you are running? So the application entirely fails. Users may not be able to access it. The accessibility is not there because the hardware already failed. My app is not running. So this is not required in a business scenario. So what causes this kind of failures that we need to aware of that? So there is a possibility that the network may fail, and the processor may fail, motherboard may fail, the power may be fail, the cable might be failing, the network may be failing. So what kind of network failures are there? So when you see that your router can fail, your switch can fail, even your network NIC card can fail. Okay, these are the different type of failures. When it comes to cable, your RJ45 cable would fail, which is the one which basically connect your system with your switch. Basically that is the end point. And power failure, now you are relying on an electricity power, so there is a power cutoff. Okay, then you are gone. So you have a UPS system, which is managing this. Suppose if this UPS system fails, what happens? You should have another UPS system which is backing this. So multiple source of power is required, and when a motherboard fails, again your system is gone. When a processor fails, again it's gone. Network card failure, yeah, this is a network card failure. That's a separate point given here, right? Now what's the advantage of cluster technology? This eliminate nearly any of this kind of failure associated with a single computer. So when you run your apps using a single computer, this kind of failures are possible, so that can be eliminated. If your hardware associated with one system, again this is ultimately your apps fail, so the cluster enables you to migrate your applications automatically to another system. So in this the second one, what happens, suppose let's say your app is running here, this system fails, the app will be migrated to here, because the cluster scenario, the storage is a shared storage, it's a shared storage. So this is shared across all your systems, all your nodes. So that's the advantage. Now suppose this fails, your app will be already here, so the same app is again taken and it will run from another system. Fine. So the reasons for implementation of your cluster. Okay, this really depends on your business case. So the time with the availability is very important. So how long your application should be available? Is it available only for 2 days in a week, or it is available for 24/7? So that defines the availability. And your application is only required for the daytime, and nighttime, okay, it's not running, okay, no users are there to use it, okay, that again defines the availability. So in case of a mission critical application, something like air traffic control or shopping cart applications, so the behind the scene, we will be using a lot of Oracle databases, Exchange servers, app servers, mail servers. This should not go down, and that's why we call this kind of apps as critical applications. They should not go down, because at any time users will be accessing these applications. Okay, so we need to basically improve the availability of all these things. That's why we need a cluster. And also it reduces the downtime. So when the system goes for a downtime, in case of a hardware failure, right? So your network card is gone, then you need to bring a network card from the market, you need to fix it, again you need to power on your system. In case of any drivers required for your network card, you need to install it, fix it, then only it will work. This takes a considerable amount of time that need to be avoided. So because during that time my app is not available, my customers obviously are unable to access my app. So that's not good for a business scenario. That's the reason why we need a cluster for running the mission critical applications. Okay, now are you planning for a failover cluster? Yes, then we should know what a failover cluster is. Okay, basically the failover cluster is a shared storage. Okay, the backbone of any failover cluster is a shared storage. The shared storage is shared across multiple systems. Let's say this is system 1 and system 2, node 1 and node 2, we can say that. So this shared storage connected with this host, maybe node 1 and node 2, with the help of a fiber channel or SCSI or iSCSI. So this is the way the system interact with shared storage, and again the choice of fiber channel or iSCSI purely depends on the business needs and or at what rate you are just reading the data from your shared storage. That's purely depends on your business case. According to that we can define it or we can use it, sorry. So accessing to this shared storage is normally managed by the set of softwares when we use Windows clustering or services, or otherwise if you are using Red Hat based Linux. So it purely depends on the type of operating system which you are using. Now this basically takes care, the cluster software takes care of accessing your shared storage. Fine. So the advantages of the shared storage. So why do we go for a shared storage? Now let's come back to the scenario. Instead of having a shared storage here, let's say that so I am just going to have a local disk here. Let's say I'm going to have a small local disk here. Okay, assume that it's a disk. Now suppose this system fails, definitely the app which is available in the system which has failed cannot be migrated to the second system. This create entire chokas, because I may not be able to run the services immediately in the second system. That's the reason why shared storage is very important. So this is your data as well as your apps will be available on a shared storage. So the data management in the cluster will be very easier. Data living in a central location, so that it's a shared storage central location. From that you can access it. You no need to worry about data synchronization. Let's say what is data synchronization? When you have let's say multiple nodes. Let's say for example, I'll just use another scenario. Let's say that I have two different systems. Now I have a hard disk. I have a hard disk here. Assume that it's a local hard disk, it's not a shared storage. Now whatever data available here need to be synchronized with this one. Suppose if you want to create a failover cluster, every time this is very important. That's a bigger headache. Instead of that, better we can go ahead with a shared storage system, so which will make our task very simple. And now here the advantage, if first one of your node fails and second node automatically assumes the control, that means your app which is running here will be migrated to the second node or third node. Already I have explained it. So virtual server or a virtual host, so we can say that it's a app or a service which is running on a cluster, and this is controlled by one node at a time. That's again a very important one. So the services which are running is normally running on a single node, not at multiple nodes. So the lock mechanism is used here for disk access. That means controlling node does it. That is so let's say for example you have an app running on this machine, so access to the shared storage is allowed only for this node, not for other nodes. Okay, access for the data concerned to this application, so that you are protecting that data which is already on a shared storage. Now there are certain essential terms we just need to know to understand the cluster. Now in a cluster scenario, we have multiple systems. Let's say so I create what I do, I just create one more example. Like I have a cluster systems. Okay, suppose a node fails, this node fails. Let's say this node, I'm sorry. Suppose, what happened? This node. Suppose this node fails. Okay, what happens? How this node, the second node or the third node, assume that this is node number 1, node number 2, node number 2, together it is in a cluster. How this node comes to know that this node is out or this node is not running? That's the reason why we need a heartbeat. So heartbeat normally runs, it's just a kind of a ping, basic ping happens in a network. So we can take it in that sense. So there is a Ethernet connectivity between these systems. So which is basically connected with the help of a crossover cable or a serial interface which is connecting two of your nodes. So the cluster communication is the other term we need to understand. So communication can occur in a private network segment or in a mixed network segment. So you'll have multiple type of networks to connect your system. So this is one network. Maybe this is called as a management network. Let's say management network, or otherwise you will have one more network which is used to connect the same machines, which is going to be the public network, where the users will be accessing your apps, and you may be using another type of probably another type of network which is used to connect all other three machines, which is connecting your shared storage. Okay, kind of different networks we can have. Communication basically occurs through this private network segment or mixed network segment. It purely depends. Cluster disk, so the hard drive that is shared by two or more cluster nodes. So that is the disk which is shared by two or more nodes, and using a shared data bus, which can be an SCSI or a fiber channel. So how this disk is going to be connected with this nodes. This is either iSCSI or a fiber channel. And also we can say something about a private disk. So each of the node also can have its own local disk available with it. So this is also possible. So a set of data will be stored here, something like your operating system, which is running on this particular host, and so on. So OS, application, swap file, these are the things which are normally available. And cluster node is the one which is taking part in a cluster, and it's a physical system, we can say that, and or otherwise we can say that it's a real server in a Linux cluster. And quorum resource, it's again particularly available in Windows and Red Hat clustering clusters. And so this is a disk or a disk partition which contains the cluster configuration data and recovery log. So cluster management and configuration data is, you know that what is a configuration data is how the systems are being configured, and the management information also stored in that file, and in case of failure, how to recover. All those details will be available here. So virtual server is a collection of cluster node that appears as a single server to its client, and with the help of a name and IP we can access it. Now failover, virtual server moving from one physical node. Let's say you have an app running here. This is migrated to this one in case of a failure. So this is called as a failover. When it happens, so when this node fails, automatically this will happen. Okay, fail back. So what is fail back? Now your system is back. This is ready. Now what happens? The app which is running here automatically migrated to this system. So that is called fail back. Okay, so let's see this architecture, cluster architecture. This is what I have been trying to explain. So you have multiple nodes, two nodes. You can see that different type of networking used here. For cluster storage, one network, and it is shared over iSCSI connection. The storage is shared over iSCSI connection, and clients are accessing the services through different network. And there are two different types of failover cluster designs. One is active, another one is active passive, another one is active active. So active passive clusters, the basic common thing is, in any failover cluster, the basic common thing is the shared storage. So you have an active node and you have a passive node. Very simple. Active node is the one which is basically running your app. Now this passive node comes to active when this fails. When this fails, this becomes active, and this app again start running from here. So there are certain advantages for this. So there won't be any single point of failure, okay, possibly, and in case this fails, your apps are still running. And normally the shared storage normally follows RAID technology. So a better example is RAID array, hardware RAID array. So in the hardware RAID array itself managed by a set of servers. Maybe one of the server fails, and the second server taking this into the control, so that your storage will not go down at any point of time. So shared nothing architecture, this is another type of architectures, no resource access and in case of a multi-nodes. And so here how things are working, only one node can perform a read or write, and other node or the monitor node which looks or it's keep on monitoring the active node, right? In this case, the active node is monitored by the passive node when and it detects for the failure. When it fails, automatically the app will be migrated to here. So here one of the disadvantage, so this also consume power, this also consume power in terms of power consumption. So both nodes should be up and running, otherwise this doesn't work. And active clusters, again another scenario. So we have two different nodes here, 1 and 2, both are using a shared storage, and one of the first node I have a SQL server running, and second node we have a Exchange server running. Now the same scenario, this node monitors this node monitors this node. In case of a previous one, the passive node is monitoring other node. Here this one monitors the second node monitors the first node. In case this fail, the SQL will be migrated to the second node. In case suppose this node fails, the service which is running here, that is the Exchange server, which will be migrated to this node 1. So this is the way basically it works. And there is another type of clustering which is called as n-tier clustering. In an n-tier clustering, you have multiple nodes, node 1, node 2, node 3, like multiple nodes will be there. These are connected in a LAN network, and so it uses a shared storage, and so shared storage is connected through all these nodes with the help of a fiber channel switch. And this typical configuration is called 3-node n-to-1 cluster. Okay, there are two different types, n-to-1 and n+1. This typical configuration is n-to-1 cluster. So what is this n-to-1 cluster? Among this nodes, one is going to be a passive, right? So look at this picture. We have only one passive and remaining all active nodes. So this is hosting an Oracle application, this is hosting an Apache application. Now if any one of this fails, let's say this fails, automatically Oracle will be running in the node 3, that is in the passive node. Now when this is ready, automatically this Oracle service again start migrated to, it will be migrated to the node 1. And n+1 architecture, okay, n+1 architecture, this do not happen. The passive node, once this node fails, automatically the services will be migrated to passive node, and when this node is ready, it will not run the services back in node 1. Instead of that, this n+1 architecture, this node became the passive node. Okay, that's the way it works. Now for your business case, you want an cluster, you are just wanted to plan it for your clusters, and there will be a lot of confusion which model I should go for. Definitely you are you have your application is having lesser demand, then you just wanted to try out a cluster. You can start with single node model. Basically we have 5 different models. It's the choosing a model which purely depends on the business needs or the use cases of your organization. And the single model advantages, so this is the first step towards a multi-node. So you start with a single node, then probably you will be migrating to a multi-node model. So a failed service can be restarted, and here only one disadvantage is there, that is a SPOF, single point of failure. Now in a production scenario, this is not much widely used. And the second type is called dedicated secondary node, active passive model. So the failover capacity is there, single point of failure can be removed, and the disadvantage is passive node do not manage cluster resources. That is again another disadvantage. So we have 2 different nodes, so one active node and one passive node. The passive node do not manage the cluster services, and again I need to invest extra hardware, and in terms of money again it's an extra expenditure. And the another type, the third type is dedicated secondary node model, and or otherwise we can call it as a split model. So this is similar to active passive, but there is a small difference. Active node hosts clustered and non-clustered apps. So that means this active node runs clustered and non-clustered application. There are two different type of applications are there in a practical scenario: clustered apps and non-clustered apps. Some apps cannot be clustered. In that sense, this will be running two different apps, that is clustered apps and non-clustered apps. One disadvantage is there: if this node goes down, the clustered apps will be running on the passive node, not the non-clustered apps. Okay, because all these non-clustered apps are lying on the local disk of this machine, so that's why it cannot be started. Fine. And the fourth type is a high availability with static load balancing, active model. So this runs clustered apps in each node of the cluster. There is no standby server. That is another advantage. So all the servers are utilized to run the services. The two different apps or multiple apps you can statically run using load balancer over two nodes or n nodes. Purely depends on how many number of nodes you are using in your cluster. The multiple instances of the same app statically load balance on several nodes, so that your application downtime will be very minimal, and it is not going to be down for any cause, even though one of your node goes down. And also it really improves the performance as well. And the last model is hybrid model. So it's a mix and match of the previous models. So according to the business case, we can mix multiple models so that it can be used for hosting our applications. And that's all about failover clustering, and these are the references. Thank you for watching the video. Thank you.